Hi, good day everyone. I am Jelson and was Goya. Welcome to our number theory channel. And this time I will be going to elaborate the properties of Euler's totient function. Euler's totient function or phi function is a very important number theoretic function having a deep relationship to prime numbers and the so-called order of integers. The totient function of n of a positive integer n greater than 1 is defined to be the number of positive integer less than n that are coprime to n, and the pi of 1 or the totatives of 1 is defined to be 1. In addition, it measures the breakability of a number. At a given integer n that are relatively prime to n. When we say relatively prime to n, it means the two numbers a and b are relatively prime if they have no common divisors apart from 1. For example, 8 and 15. The prime factors of 8 are 1, 2, 4, and 8. And the prime factors of 15 is 1, 3, 5, and 15. And as what have you observed, their only common is 1. Therefore, 8 and 15 are relatively prime. Are you still with me? Now, totient function also is written using the Greek letter pi, as what have you seen. In addition, it is the number of integers k in the range k is greater than or equal to 1 and less than or equal to n, for which the common divisor of the GCD of n and k is equal to 1. Theorem 1.5. If the integer n is greater than or equal to 1 as the prime factorization, then you have to use the base formula p raised to k multiplied by 1 minus 1 over p, where your p here is a prime number that is raised to any positive numbers. For example, you have to find the totatives of 9. As what have you observed, 9 is a perfect square number, and it is prime, and the prime factorization of 9 is 3 raised to 2. Are you still with me? Now, 3 raised to 2 is same or similar from p raised to k. Therefore, your p here is 3, which is the prime number, and your 2 here is the any positive numbers that is raised. Okay? Now, your p is 3 and k is 2. By substitution, 3 raised to 2, which is your p raised to k, multiplied by 1 minus 1 over 3, which is your p. Then simplify. Did you get the answer? The answer is 6. We have here 4 properties. Number 1 properties. If p is a prime number, then the totatives of p is equal to p minus 1. For example, the derivatives of 7 is what you observed. 7 is a prime number. Therefore, by applying our property, as stated, any prime number is subtracted by 1. Therefore, the derivatives of 7 is 7 minus 1 equals is 2. Yes, it is 6. Properties of 5 functions. If p is a prime number, then the derivatives of p raised to 2 is equal to p raised to 2 minus p. Are you following? For example, we need to find the derivatives of 529. Yes, you're right. 529 is a perfect square number. Therefore, their prime factorization is 23 is multiplied by 23, or 23 raised to 2. Now, by using our property, it has been said that p raised to 2 minus p if p is a prime number. Therefore, your 23 here is a prime number. Then you can apply our property. So 23 raised to 2 minus 23 is equal to 506. Why? Because 23 raised to 2 is equal to 529 minus 23. Yes, the answer is 506. Important properties of 5 function is, if p is a prime number and k is the element of natural numbers, then the derivatives of p raised to k is equal to p minus 1 multiplied by p raised to k minus 1. It sounds complicated, right? But trust me, it is simple. For example, you have to find the derivatives of 29,791. Yes, you're right. It is a perfect cube number, which is 33 raised to 3. The property number 3 is similar to property number 2. Have you observed it? Yes, you're right. It is similar, but in property number 3, it deals numbers that are raised by greater than 2. Now, we have here the derivatives of 31 raised to 3, wherein your 31 is a prime number. Then, you can apply our third property, which is p raised to k minus p raised to k minus 1. Now, your p here is 31 raised to k, which is 3 minus or subtracted by the derivatives of 31 raised to 2, wherein your 2 here is 3 minus 1. Did you get me? Now, 31 raised to 3 is 29,791 minus 31 raised to 2 is 961. To find the total, or this 29,791 minus 961, the final answer is 28,830. 28,830 numbers that are relatively prime to 29,791. Properties of five function is, if P and Q are distinct prime numbers, then the totatives of P and Q is equal to the totatives of P multiplied by the totatives of Q. As what I have said earlier, the Euler's Totient function is a multiplicative function. Okay? As what have you observed, 400 is not a prime number. Are we clear? Okay, now you have to find the prime numbers of 400. Okay, so now you have here 2 and 5. Now 2 and 5 are prime numbers, therefore they are distinct prime numbers. Did you get me? So 2 raised to 4 is equal to, yes, 16. Multiplied by 5 raised to 2 is equal to, yes, 25. So 16 times 25 is 400. Okay, going back to the properties that we had been discussed earlier. If any number, if P is raised into numbers that is greater than 2, then you have to use the property number 3, which is P raised to K minus P raised to K minus 1. Can you still recall? Okay, by applying the property, so you have to use this. The totatives of 2 raised to 4 minus the 2 raised to 3 is equal to 8. Are you following? Okay, multiplied by the totatives of 5 raised to 2. What property is that? Yes, very good. Property number 2. So 5 raised to 2 minus 5, which is 20. Now, multiplied it. 8 is multiplied by 20 is equal to 160. On the table, the following table shows the function values for the first several natural numbers, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 15. As what have you observed, all numbers that are prime numbers, they are just subtracted by 1. Like for instance, number 2. The totatives of 2 is 1. What else? Yes, number 5. The totatives of 5 is 4, which is 5 minus 1 is 4. What else? Yes, the totatives of 7. The answer is 6. What else? The totatives of 11 is 10. Can you still recall the properties? What property is that? Yes, very good. Property number 1. Any number that is prime number, you have to subtract it by 1. Very good.